Okay, when you're solving trig equations, there are two formats. One is to solve for solutions that are in a certain replacement set, and that's what this one's all about. As you can see, it says find all solutions between 0 and 360 or between 0 and 2 pi. Or you could be finding the general solutions, because we know that trig functions are periodic and they repeat their values, and so we would have to put them in a more general case where we would have to include multiples of pi or 2 pi added to them. So what we're going to do is we're going to solve these equations over this replacement set. Now, for these first 10 problems, the trick is to isolate the trig function. Get it all by itself on one side of the equation and then refer to your unit circle to the values so that you can find the angles that correspond to the numbers. Alright, now if you haven't tried these, try the problems first before you watch me work them out. Because that way you'll see what you're doing right, what you're doing wrong, and then hopefully if you're doing something wrong, you'll be able to figure it out and remember it a little bit better than if you just jump right to the video without having invested a little thought about the problems first. Alright, so make sure that you've tried these first. So I'll pause my moment here so you can stop the video and try the problems if you haven't already done so, and then I'll kick right back in. So here's my pause. Now I'll kick right back in. The first problem, it's very close to having the trig function isolated by itself. I just have to get rid of the 2. So I'm going to divide both sides by 2, and I get the sine of x is equal to negative 1/2. Well, what angles between 0 and 360 or 0 and 2 pi, I wrote all my answers here or all my angles in degrees, but we could do this with radians as well. So what angle or angles have a sine function value that's negative 1/2? Well, that happens here at 210 and here at 330. So x is equal to 210 degrees, 330 degrees. Those would be the two answers. Most of these problems are going to have 2 answers or 4 answers or maybe a single answer. All right, and from what I just looked at, I have not worked them out yet. I'm just kind of working them out as I go. Now problem 2 is a little different than problem 1 because it does have the trig function without any constant or any factor or something being added or subtracted, but the trig function is squared. And you may remember from your quadratic days that when you had something like y squared equals, let's say, 16, you took the square root of both sides. You got the absolute value of y was equal to 4, so y was equal to plus or minus 4. You picked up a couple values here, so that's what I'm going to do here. I'm going to take the square root of both sides, and I get the absolute value of the tangent of x is equal to the square root of 3, whatever that is, about 1.732. And then I'm going to drop the absolute value, so I get the tangent of x is equal to plus or minus the square root of 3. Now, I didn't list the tangent values. You can make a list or you could look them up online. But the tangent values where the angle that I take the tangent of that gives me either a positive or negative square root of 3 over 2, that's when, remember, tangent is sine over cosine. And so if you have the sine of the value over the cosine of the value, then what that means is that it has to simplify to the square root of 3, and that happens when the numerator is the square root of 3 over 2 or negative square root of 3 over 2, and the denominator is a half or negative a half. So that happens at, like, for example, 60 degrees, because the sine is the square root of 3 over 2 all over a half. That's the square root of 3 over 2 times the reciprocal of a half, or 2 over 1. The 2's cancel, you just get the square root of 3. So this is going to occur at 60 degrees, 120 degrees, because I'll just get a negative square root of 3 over 2. Drop down here to 240, I'll get a positive square root of 3 over 2. And then all the way down to, where's that, 300. Because that will give me a negative square root of 3 over 2. It's a little trickier with tangent because you should have these ones memorized already, and since I've already written them out, we can just refer to it. But you have to think, and I've got a tangent here, I've got a tangent here. Oh, just 2 of them on this first side here. Alright, so that's not so bad, I guess. Alright, this next guy is a lot like the first problem. I have a 2 times the sine of x, so the first step is to get rid of the 2 by dividing by 2. And I get the sine of x is equal to the square root of 3 over 2. Well, what's x equal to? Well, let's go back to our sign. When do I get the square root of 3 over 2? I get it at 60. And I get it at 120. And I don't have another value in there that gives me a positive square root of 3 over 2. So there are my answers here, and here, and here. Isolate the trig function, then refer to the table, or from your memory, you should have these memorized by now, to find those angles. And again, I'm just doing all my angles in degrees. This is the same as pi over 3, and this is the same as 2 pi over 3. Alright, we jump over to here. This is a lot like this problem also, in that I've got to get rid of the square root of 3, that's times the tangent of x. So the first thing I'm going to do is I'm going to divide both sides by the square root of 3. Now that's going to give me a radical in the denominator. And I probably would want to rationalize this by multiplying top and bottom by the square root of 3. And I would get the square root of 3 over 3. Now again, it's a tangent. It's the only other tangent that was on this first side. And they're not listed here. But look back here. The tangent is the sine over the cosine. So if this was like a half here, and this was the square root of 3 over 2 there, it would simplify to the square root of 3 over 2. And the reason I write that is because there are certain trig functions where certain angles for the sine and the cosine to be those values, or those opposites. So I'm looking at the sine to be the square root of 3 over 2, excuse me, to be a half, and the cosine to be the square root of 3 over 2. Well, that's going to occur right here at 30 degrees. And then it's also going to occur at 210 because I'll have a negative over a negative, and that's still a positive square root of 3 over 3, so that's also going to happen at 210 degrees. So it's a little trickier with tangents because they're not listed in the table and they're probably not memorized. Hopefully these guys are. Alright, now this problem is a little bit like problem 2, except that first I have to do the step of adding 1 to both sides. You want to add a 1 to both sides, and I get the cosine squared of x is equal to 1. Then I take the square root of both sides. Of course, the square root of 1 is 1. So I get the cosine of x is equal to plus or minus 1. Alright, so I have to find when the cosine, which is the middle column, is equal to 1, and that happens at 0. Or is equal to negative 1. There it is, 180 degrees. And those are my two answers. Now this one is a little bit like the problem that I just did, except I've got 2 steps to do to get the cosine squared x by itself. Here I have to subtract 4. I get 2 cosine squared x is equal to 1, then I'm going to divide both sides by 2. And I get the cosine squared of x is equal to half. Now be careful, that half is tempting, because you see halves over here. But this is cosine squared x. I have to take the square root of both sides. And the square root of 1/2 is the square root of 1 over the square root of 2. And if I rationalize it by multiplying top and bottom by the square root of 2, this is the square root of 2 over 2. So now I have the absolute value of the cosine of x, yeah, because I took the square root, is equal to the square root of 2 over 2. I drop the absolute value, I get the cosine of x is equal to plus or minus the square root of 2 over 2. So I'm going to have 4 angles here. For cosine, square root of 2 over 2, that happens at 45. Hopefully you can still read this, my pen's starting to fail. 135 degrees, 225, and all the way down here to 315. So I have 4 answers there. Alright, let's see if we can finish these up here. Let's see if I got a marker that's a little bit, got more ink. We'll try this one. Now here I've got the sine of x on both sides, but it's not as bad as it looks. Just get the sine of x on one side, just like you would get the variable on one side. I'm going to go ahead and subtract 5 sine x from both sides. I get negative square root of 3 is equal to negative 2 sine x. I'm going to divide both sides by negative 2, and then I'm going to flip-flop the sides, and I get the sine of x. Negative over negative is a positive square root of 3 over 2. I don't think I've had that one. Oh, yes, I did, right here. The sine of x is the square root of 3 over 2, so I already know my answers. My answers are 60 degrees and 120 degrees, but it was a little bit of work to get to that point. Be very careful. Now this one is a lot like this one, and then I have 2 steps before I take the square root of both sides. I've got to get the sine squared of x by itself on one side first, so I'll undo the stuff around it, just like we've always done. Undo adding, subtracting first. And I have 4 sine squared x is equal to 2. Then I'll divide both sides by 4. And I get sine squared x is equal to 1/2. And then I'm going to take the square root of both sides. Now I just did this a second ago. The square root of 1/2 is the square root of 2 over 2 when you simplify it. I'm not going to do it all over again. So I get the absolute value of the sine of x is equal to the square root of 2 over 2. I drop the absolute value, the sine of x is equal to plus or minus the square root of 2 over 2. So what values does that occur at? Well, for sine, the square root of 2 over 2 happens at 45. I also have to consider negative square root of 2 over 2. So at 45 degrees, at 135, at 225, and then all the way down here at 315 degrees. And those are my answers. So that's a degree sign there. So I have those and I have these right here. Almost done. This one is a lot like the one I just did, except this time I am going to add 3 to both sides. And I get 4 sine squared x is equal to 3. I'll divide both sides by 4 to get the sine squared x all by itself. And I have 3/4, so I'm going to take the square root of both sides. Now the square root of 3/4 is the square root of 3 over the square root of 4, which is the square root of 3 all over 2. I don't need to rationalize my numerator, my denominator is a rational number, that's what I want. So this is the absolute value of the sine of x, and this is equal to the square root of 3 over 2. Drop the absolute value, you pick up the plus or minus. I don't know if your teacher's skipping that step, it's okay if you do, if he's doing that. Otherwise I'd put it in. And then I have to find those values where my sine is either positive square root of 3 over 2 or negative square root of 3 over 2. Positive square root of 3 over 2 happens at 60 and at 120. And negative square root of 3 over 2 happens at 240 and 300. Alright, this last one's a nice little break because I don't have to take the square root on both sides. I am going to, here, let me smear it a little bit. I'm going to add 8 to both sides. I get 16 cosine x equals 8. Divide both sides by 16. I'm being awfully lazy here and just attaching it to steps. I get the cosine of x is equal to 8 over 16, which simplifies down to 1/2. Well, cosine is equal to 1/2 at 60 and at 300. So x is equal to 60 degrees. And x is equal to 300 degrees. Now, okay, I'm back. I have a new screen of problems. I accidentally erased the 0 to 2 pi, that's why it's so darker. And I have some interesting equations, some that are similar to the ones that were on the previous page, and some that have a twist to them, that are going to require some factoring. Now, the first one has a cotangent, which, I barely can remember a tangent at times. This one has a cotangent, so I'll show you what to do, what happens when you have a trig function and maybe is a trig function and you're not as familiar with the values. I would still isolate it, so I'm going to add 1 to both sides. And I get the square root of 3, cotangent of x is equal to 1, then I'm going to divide by the square root of 3. And I have the cotangent of x is equal to 1 over the square root of 3. And you say, well, rationalize it. Well, multiply top and bottom by the square root of 3. Well, what if I took the reciprocal of both sides? This would be the tangent of x is equal to the square root of 3, which I think we might have had on the first side. So tangent of x is equal to square root of 3. This is like square root of 3 over, if it helps, over 1, which is like square root of 3 over 2 over 1/2. So I need a positive square root of 3 over 2. I need the sine to be positive and the cosine to be positive, or them both to be negative. So that would happen at 60. And also at 240. Now I was looking and I noticed that some of the problems have x's as the variable and some of the problems have theta as the variable. And when I would set up trig quizzes like this or trig assignments like this, a lot of times I would tell my students, well, if it's in x, put it in radians, and if it's in theta, put it in degrees. But I don't think he minds either way, but I'm going to finish it out that way. I'm going to do, if it's in x, I'm going to do it in radians, and if it's in theta, I'm going to do it in degrees. So, the secant of x is equal to the square root of 2. I'm not great with secants, but I know secant is 1 over cosine, so I take the reciprocal of both sides. Kind of like I did up here. I get the cosine of x is 1 over the square root of 2, and I am going to have to rationalize that. So I have the cosine of x is equal to the square root of 2 over 2. Well, a positive square root of 2 over 2 for cosine, that happens at 45, which is pi over 4, and it happens again at 315, which is 7 pi over 4. And there are my answers. Now, if he's okay with degrees, stick with degrees the whole time. Next guy up, divide both sides by -4. I get the cosine of theta is equal to, now I can simplify this, 2 goes in once, goes in twice. I get negative square root of 3 over 2. That's one of those favorite values. And since I have a theta, I'm going to do this in degrees. So that's going to happen at 150 and at 210. 150 degrees and at 210 degrees. You can see how much faster you can do these problems if you don't have to go back and look at the table every time, if you have these memorized. Now this next one is kind of a weird one. I think he put it in here just to kind of see what was going on, because he gives you a fraction, he gives you a 3, you think something weird about this. No, you still have to simplify, just subtract 3 from both sides. Now, this 7 halves is 3 1/2. 3 1/2 minus 3 is 1/2. So that doesn't look so weird. And since I'm using theta, I'll get this one in degrees. Cosine is 1/2 at 60 and at 300. 60 degrees and at 300 degrees. Now begins our problems where we're going to have to do some factoring. Now you're used to factoring stuff that looks like this. X squared minus 4x minus 5 equals 0. You'd factor x minus 5 times x plus 1, and then you'd set x minus 5 equal to 0, or you set x plus 1 equal to 0, and you'd solve each one of these simpler equations. We're going to approach it the same way. It's just that instead of an x and an x, we have sine of x squared minus 4 times the sine of x minus 5. So I'm still going to factor it. It's just not going to be an x and an x. It's going to be a sine of x and a sine of x. And I'm going to need a, just like I had up back here, I'm going to need a minus 5 and a plus 1. So I said sine of x minus 5 equal to 0, or sine of x plus 1 equal to 0. Notice how I factor it, and then I said each factor equal to 0. And then I'm going to solve these two simpler looking equations. I'm going to add 5 to both sides. I get the sine of x is equal to 5. Now right away, I'm hoping that you look at this and you say, oh, something's wrong. The sine of x is never bigger than 1. Yeah, there's no solutions here. That's a contradiction. But over here, if I subtract 1 from both sides, I get the sine of x is equal to -1. Now that can happen. The sine of x can be -1 way down here at 270. So I have a single answer. Usually, when you factor, and you're going to see this in the next example, you have actually extra answers. This one has one less than the rest of them have been so far. So over here, I'm going to approach it the same way that I did here. I'm going to try to factor this, kind of like reverse FOIL here. I'm going to put a 2 sine x and a sine x. It's going to be a 1 and a 1. I need a minus in the middle, so minus here, plus here. I said 2 sine x plus 1 equal to 0, or the sine of x minus 1 is equal to 0. I'm going to subtract 1. I get 2 sine x is equal to -1. Divide by 2. I get the sine of x is equal to -1/2. Well, when does the sine of x equal -1/2? At 210, oh, this is x, so 210 would be 7 pi over 6. Oh, I forgot to do that. I went to degrees. This is the same as 3 pi over 2. Or, let's see, not just at 210 or 7 pi over 6, but also at 330, which is 11 pi over 6. So this happens at 7 pi over 6 and 11 pi over 6. Or 210 degrees, 330 degrees. Now, are those my only answers? Well, this is just this one. Over here, I add 1 to both sides. I get the sine of x is equal to 1. Well, that happens. The sine of x is equal to 1 at 90 degrees, which is pi over 2. So I actually have 3 answers on this one. This one I only had 1. This one I had 2. All right, now the last 3 problems are all going to be solved by factoring. You can kind of see it coming because you've got a trig function that's squared. Now you had trig functions that were squared on the other side, but there was no other term that had the trig function. It was always a constant. So in this case, and it's really tempting to want to divide both sides by the cosine of x, but do not, you will lose roots. Okay, you will lose answers. Subtract the cosine of x from both sides. Subtract the cosine of x from both sides. Then factor out the cosine of x like a GCF. This would be the cosine of x minus 1. So if you distribute it, you get right back to where you started. Set this equal to 0. Set this equal to 0. Well, the cosine of x is equal to 0 at 90 and at 270, or at pi over 2 and 3 pi over 2 if I keep it with radians. And here I'm going to add 1 to both sides. I get the cosine of x is equal to 1. Well, the cosine of x is equal to 1 and 0. So again, I have 3 answers. Now if you want to, you can write it as a solution set so that you can put them together if the teacher's okay with that. Or you can just write x equals 0, pi over 2, 3 pi over 2 like this. List them one of these ways. It's up to you. It's up to the way your instructor prefers. Another factoring problem. This one is all set up. Looks like a 2 cosine x and a cosine x equals 0. It's going to be a minus 1 and a minus 1 for both of them. So I said 2 cosine x minus 1 equal to 0, or cosine of x minus 1 is equal to 0. So I'm going to add 1. Actually, I'm going to add 1 on both. And I get 2 cosine x is equal to 1. Then I'm going to divide here by 2. I get the cosine of x is equal to a half. Over here, I get the cosine of x is equal to 1. Well, both of these, the cosine of x is equal to a half at 60 or pi over 3, and at 300 or 5 pi over 3. Okay? And over here, the cosine of x is equal to 1 at 0. So you could kind of circle all of this, kind of do something like this. I've had students do that. Or you can write it out. And I usually, if I have a lot of answers, I usually put them in increasing order. It just makes it easier for the instructor to make sure you have them all. And that way you can keep track of them a little bit yourself. All right, 2 to go. Cosecants. Don't worry, I'll show you what to do. You are going to have to factor. You can see it looks like a quadratic. A cosecant x and a cosecant, well, if I can write it, x. And it looks like it's going to be a minus 2 and a plus 1. So the cosecant of x minus 2 is equal to 0. The cosecant of x plus 1 is equal to 0. Now, this is not the same as it was here. See, the sine can't be bigger than 1, but the cosecant can be. If I add 2 to both sides, I get the cosecant of x is equal to 2. Now remember, cosecant is 1 over sine, so if I take the reciprocal of both sides, I get the sine of x is equal to a half. That makes sense. And then over here, I'll subtract 1. I get the cosecant of x is equal to negative 1. Take the reciprocal of both sides, I get the sine of x is equal to negative 1. Because the reciprocal of negative 1 is negative 1. Think of negative 1 as negative 1 over 1. You flip it, you get 1 over negative 1, it's still negative 1. All right, so a half is this degrees? No, this is x. So at 30 degrees, or pi over 6. And at 150 degrees, which is 5 pi over 6. All right, and then this one here happens at, I think it's 3 pi over 2, 270. Yes, it is. X is 3 pi over 2. And again, you can write it like this, whatever your instructor is okay with. I actually, myself, I would prefer it this way. You know, just kind of at the bottom, show me that you know that all those are answers. All right, the last one, we start with a cotangent, we're finishing with a cotangent. Let's see what happens here. Now, this is going to require factoring, but not the way it's set right now, because I need all this on one side. I need it in standard form, set equal to 0, set equal to 0, set equal to 0, set equal to 0 here. So I'm going to subtract, actually I'm going to write this, I'm going to put this one first and this one last, but I'm going to subtract 2 cotangent theta from both sides. So that's going to give me 0 out here, but I'm going to write cotangent squared theta minus 2 cotangent theta plus 1. This factors, but it factors into two binomials that are the same exact binomial. Looks like a -1 and a -1. So you don't have to set them both equal to 0. You can just set one of them equal to 0. It's kind of nice when it's the same factor. Add 1 to both sides. I get the cotangent of theta is equal to 1. Well, again, if you're not happy with cotangent, take the reciprocal of both sides. I get the tangent of theta is equal to the reciprocal of 1, which is 1. Now that happens when the sine of theta over the cosine of theta, when they're the same values. And that happens here at 45 degrees or pi over 4, they're the same value. And it also happens at 225, which is 5 pi over 4, they're the same value. So my answer, this is in theta, so I'm going to write it as 45 degrees and 225 degrees. And those are my answers. Now, equations with trig functions can get a little bit more complicated than this. I don't know how deep he's going to go, but if he's going to go one more section of equations, they're going to be a little bit more complicated than this. So you've got to make sure that you practice this and you feel comfortable with it, and not just copy down what I have written down, but have a good feel for this stuff, because if he goes one more section, and he might, because there's other kinds of equations that aren't up here, if he goes one more time, it's going to probably involve some trig identities, or maybe he's going to show you some of the stuff with the double angles. It could be a variety of different things. Alright, so hopefully this helps you out a little bit.